Hi YouTube, Tim Uckert here. In this video we're going to continue with my Algebra 1 Honors Finals review. We're up to problem 21. So we're going to factor x squared plus 10x plus 25. Now there's a couple different ways you could do this. You could list all the factors of 25. We have a positive and a positive here. So I'd stick with positive factors. So I could do 1 times 25 or 5 times 5. 5 times 5 is 25 and adds to 10. So you could write this as x plus 5 times x plus 5. And when you multiply something by itself, you got to understand that that something is squared. So this could also be x plus 5 squared as a solution. The other thing you could notice is that this is a perfect square trinomial, and you can check that. Perfect square trinomials take the form of a squared plus 2ab plus b squared, and they factor to the quantity a plus b squared. So you want to check, once you figure out what a and b are, that the middle term here is 2 times whatever a and b are. So in this case, a squared is the first term, so a squared would be x squared. And b squared is the last term, so b squared would be 25. So if we want to solve for a, we got to take the square root of a squared. That means we have to take the square root of x squared. What we do to one side of the equation, we must do to the other. So the square root of a squared is a, square root of x squared is x. To solve for b, we'd have to take the square root of b squared, and likewise, since we're taking the square root of the left-hand side, we have to do that to the right-hand side of the equation. The square root of b squared is b, and the square root of 25 is just 5. So 2ab is going to be 2 times x times 5. So that's going to be 10x, which is our middle term here. So this is a perfect square trinomial. So it's going to factor into this form a plus b squared. A is x, b is 5. So the factored form is going to be x plus 5 squared. So with either method, you would arrive at this solution. And, getting to recognize that this is a perfect square trinomial is something you will recognize as you do more of these. And you might just see, oh yeah, that's x plus 5 squared. Okay. Let's look at problem 22. We're going to solve x squared plus 7x equals negative 10. When we want to solve these, we want to get one side equal to 0. So I'm going to add 10 to both sides of the equation to get rid of the negative 10 on the right. 10 plus negative 10 is 0. And on the left-hand side, we get x squared plus 7x plus, I didn't give myself much room here, plus 10. So now it's just factoring when a equals 1, the number in front of x squared equals 1. We have a positive and a positive here, so I'm going to list the positive factors of 10. Those are 1 and 10, and 2 and 5. And 2 times 5 is 10, but adds to 7. Okay, so we want to select positive 2 and positive 5, so the factored form would be x plus 2 times x plus 5 and that equals 0. Okay, but we want to solve. We don't want to just factor the left-hand side. So now, if I set one of the factors equal to 0, well, let's say I said x plus 2 equals 0. This is 0. Whatever this is, 0 times whatever x plus 5 is, will be 0. Now likewise, if x plus 5 equals 0, 0 times whatever x plus 2 is would equal 0. So we're going to have two solutions. One when x plus 2 equals 0. And we would solve for x by subtracting 2 from both sides here. 2 minus 2 is 0. We get x equals negative 2. And we would also find our other solution when x plus 5 equals 0. And we could solve for that by subtracting 5 from both sides. 5 minus 5 is 0. We get x equals negative 5. So our two solutions here are x equals negative 2 and x equals negative 5. All right, let's keep going. Problem 23, we're going to solve x squared plus 64 equals negative 16x. Like the previous problem, we want to get one side equal to 0, so I'm going to add 16x to both sides. So we got x squared plus 16x plus 64 equals 0. So we want to get this into factored form. You may notice that this is a perfect square trinomial. And if we just list out the factors, we have a positive and a positive here. So we'd list out positive factors. You'd see that positive 8 times positive 8, that equals 64 and adds to 16. So this would factor into x plus 8 times x plus 8, or another way to write that is x plus 8 squared. That equals 0. And in this particular one, there's going to be one unique real solution. That's when x plus 8 equals 0. So it's a x plus 8 equals 0. And we'd subtract 8 from both sides. And 8 minus 8 is 0, and we get x equals negative 8. So what does this mean? Well, this is on the x-axis at x equals negative 8. This is a parabola that opens up because there's a positive 1 in front of x squared. So it opens up, but it just touches the x-axis at the vertex at x equals negative 8. Let's take a look at this on Desmos. So if I do x squared plus 16x plus 64, you can see here that at negative 8, right here, right at the vertex, is where this touches the x-axis and then it opens up. It only touches in one spot. And that's the one unique real solution. Okay, let's keep going with problem 24. This is factor, but we're actually going to solve it. I meant to write solve because I have one side equal to 0. So let's solve it. And to solve, we will first need to factor. So we've got 16x squared minus 25. This is a difference of square problem where we have a squared minus b squared. It takes the form a squared minus b squared, and it factors to a plus b times a minus b. Okay, so the first term would be our a squared. That's going to be 16x squared. And this works when both the first term and the last term are perfect squares. When they have numbers for perfect squares, and you could multiply like x times x, or sometimes you'll see y squared here, maybe y times y. B squared is going to be our second term, which is 25. And you have to have this subtraction here. It has to be a difference. So to figure out a, we take the square root of a squared, meaning we have to take the square root of 16x squared. Square root of a squared is a. Square root of 16x squared is 4x. We take the square root of b squared to get b, meaning we have to take the square root of 25. So square root of b squared is b, square root of 25 is 5. So the left-hand side of the equation is going to factor into 4x plus 5 times 4x minus 5. And that equals 0. All right. So now again, like the previous problem, if 4x plus 5 equals 0, then 0 times whatever 4x minus 5 will equal 0. Likewise, if 4x minus 5 equals 0, 4x plus 5, whatever that is, times 0 will equal 0. So we have our two solutions here when 4x plus 5 equals 0. And when 4x minus 5 equals 0. So I'm going to subtract 5 from both sides here. 5 minus 5 is 0. And we get 4x equals negative 5. I'll then divide each side by 4. Because I want to get just x. So x equals negative 4/5 is one of the solutions. And then if we add 5 here, five minus 5 is 0. We get just 4x equals positive 5. Divide by 4 again because we want to solve for x. So the other solution is x going to be 5/4. All right, so our two solutions here are x equals negative 5/4 and x equals 5/4. All right, let's keep going. All right, problem 25. We are going to solve the equation 3x squared minus 3x equals 60. So what do we need to do? That's right, we need to get one side equal to 0. How are we going to do it? We're going to do it by subtracting 60 from both sides. Okay, so let's subtract 60 from both sides of the equation here. 60 minus 60 is 0. And we're going to have 3x squared minus 3x minus 60 equal to 0. Now, 3, 3, and 60 are all divisible by 3, so let's divide out of 3. And we'll get x squared minus x minus 20 equals 0. Okay, so we want to keep factoring we want to factor the x squared minus x minus 20. So we have to do, we're going to have to do a positive and a negative factor to multiply to a negative number and add to a negative number. And the negative factor is going to have to be one unit further away from 0 on the number line. So you could either have, so you're looking for the factors to have a difference of 1 between them. So with 20, that's 4 and 5. Those have a difference of 1. And you want the 5 to be the negative 1 because when you add 4 and negative 5, that adds to negative 1. So we're going to select positive 4 and negative 5. And this is going to factor to 3 times x plus 4 times x minus 5. And that equals 0. And fix that parentheses there. Okay, so we have 3 times the quantity x plus 4 times the quantity x minus 5. That equals 0. Now, we obviously can't set 3 equal to 0. But if x plus 4 were to equal 0, we'd have 3 times 0 times whatever x minus 5 is would be 0. Likewise, if x minus 5 equaled 0, 3 times whatever x plus 4 was times 0 would be 0. So we're going to find our two solutions. One when x plus 4 equals 0. And so we'd subtract 4 from both sides. 4 minus 4 is 0. We're just left with x equals negative 4. And we're also going to get a solution when x minus 5 equals 0. So we'd add 5 to both sides. Five minus 5 is 0, and we get x equals 5. So our two solutions are x equals negative 4 and x equals 5. Now you might want to pause the video at this point because I'm going to have to erase those two to make room for problem 26. So pause the video if you need to. All right, problem 26, factor 12x squared plus 5x minus 2. Okay, so now we have the number in front of x squared, which is greater than 1. So we have to list the factors of a. I'm going to stick with positive factors, so 1 times 12 will give me 12. 2 times 6 will give me 12, and 3 times 4 will give me 12. And then we want to pick the factors of negative 2, which are either 1 times negative 2 or negative 1 times positive 2. Now we have to look for, to take the pairs from A and C and add them, add the products of the pairs in such a way that we get 5, okay? So if I do, and let me change color here. If I do 2 times 4, that gives me a positive 8. I would have to take my other number in each pair and multiply those together and then add them. So I would have to do negative 1 times 3. That would give me negative 3. And negative 3 plus 8 is going to equal 5, which is our middle coefficient. That's what we want. So we're going to use those numbers. Now, the 3 and the 4 are going to be the coefficients in front of x. So we're going to have 3x and 4x. Now I want the 4 to multiply by positive 2, so I have to put the positive 2 over here, because when we multiply the two binomials, the inner terms will multiply together. I also want the 3x to multiply by negative 1, so I have to put the negative 1 over here, because the outer terms will multiply together. And so my factored form is the quantity 3x plus 2 times the quantity 4x minus 1. All right, how are you doing at this point? Okay, hopefully you're doing okay. Let's go to problem 27, problem 28, and then I'm going to probably stop the video at this point. And we'll make this part 3, and then we'll continue with part 4 with problem 29. Okay, so problem 27, we're going to find the solutions to 6x squared minus 13x equals 28. So we're going to have to, one, subtract 28 from both sides to get one side of the equation equal to 0. So on the left-hand, or on the right-hand side, rather, of the equation, we get 0. On the left-hand side, we get 6x squared minus 13x minus 28, and that equals 0. So on the left-hand side, we're going to factor, and a is greater than 1. So I'm going to list the positive factors of 6, which are 1 and 6, and 2 and 3. And then I'm going to list the factors of negative 28, which are 1 and negative 28, negative 1 and positive 28, 2 and negative 14, negative 2 and positive 14, 4 and negative 7, and negative 4 and positive 7. And our middle term is negative 13. So we've got to find a combination that would give us negative 13. Now, if I do, let's see, 3 here, and I multiply by negative 7, that gives me negative 21. Then, if I do the other pair, so if I would have to do 2 times the other number in the other pair, 4. So 2 times 4, that would be 8. Excuse me. So negative 21 plus 8 is going to be negative 13. So those are the numbers I want. And so my factored form is going to be 2x. Well, let me write the coefficients in front of x first, and then 3x. The right-hand side of the equation equals 0. I want the 2x to multiply by 4, so I'm going to have to add a positive 4 here, because the outer terms multiply together. And I want the 3x to multiply by minus 7, so I'm going to have to put that, or negative 7, rather. I'm going to have to put that on the inner terms here. Now we're just going to set each of those factors equal to 0 and solve for x. So I'm going to say 2x minus 7 equals 0. I'm going to add 7 to both sides. 7 minus 7 is 0. So we get 2x equals 7. Then divide by 2. And so I get x equals 7/2 is one of the solutions. Okay, and then we're going to set 3x plus 4 equal to 0. We're going to subtract 4 from both sides. 4 minus 4 is 0. We get 3x equals negative 4. And we're going to divide by 3. 3's cancel over here, and we get x equals negative 4/3 as the other solution. So x equals 7/2 and x equals negative 4/3. Okay, if you need to pause the video and write that down, please do so now, because I'm going to go ahead and erase that so we can do problem 28. Okay, problem 28. How many yards are equivalent to 648 inches? So we're going to take our 648 inches and we'll multiply by our conversion factor, which they give us. So 1 yard is 36 inches. The inches are going to cancel here. And 648 times 1 is 648. So we have 648. And that's divided by 36. That's going to be yards. Okay, so if we go over to Desmos, and we do 648 divided by 36, we get 18. Okay, so our solution here is going to be 18 yards. All right, I think I'm going to stop there for part 3 of the Algebra 1 Honors Finals Review. If this video was helpful to you, please give a like and subscribe. It really would mean a lot to me, and it really helps out. Thank you.